Hello, and welcome to this video on TCPWave's Themis Application Delivery Controller, ADC. In it, you'll gain an understanding of how the ADC works, including its load balancing functionality, which you can use to improve the performance, availability, and scalability of your application servers. Today, we'll dive deep into the technical aspects of TCPWave Themis ADC, exploring its query and response flow, SSL/TLS Termination and Passthrough methods, and delve into the heart of load balancing algorithms. Query and response flow. The journey of a request through TCPWave Themis ADC is a symphony of intelligent routing and efficient processing. Let's take a step-by-step look. Client connection. The client initiates a connection to the virtual IP address associated with the load balancer. Packet inspection. TCPWave Themis ADC meticulously analyzes the incoming packet, extracting information like destination port, protocol, and headers. Load balancing. Based on the chosen algorithm, round robin, least connection, etc., TCPWave Themis ADC selects the most optimal backend server to handle the request. Server connection. A connection is established with the chosen backend server, forwarding the client's request. Server response. The backend server processes the request and transmits the response back to TCPWave Themis ADC. Client response. TCPWave Themis ADC routes the response back to the client, completing the communication cycle. TCPWave Themis ADC offers two critical options for handling SSL/TLS encryption. SSL/TLS termination. This method allows TCPWave Themis ADC to decrypt incoming client traffic, inspect it for malicious content, and then re-encrypt it before forwarding it to the backend server. This provides an extra layer of security and enables features like deep packet inspection. Let's have a closer look at how SSL handshakes unfold in TCPWave ADC. TCP handshake. The process begins with a TCP handshake between the client and the server. This is where the TCP three-way handshake occurs: sync, acknowledge, acknowledge. Certificate check. Once the TCP connection is established, the server sends its SSL certificate to the client. The client will validate the server's certificate to ensure it's trustworthy. The client begins the SSL handshake by sending a client hello message to the server. The server responds with a server hello message, followed by its certificate. The client verifies the server's certificate. Key exchange. The client then sends a client key exchange message, which includes a pre-master secret encrypted with the server's public key. Both the client and server generate a session key from the pre-master secret. The client and server exchange change cipher-spec messages, indicating that subsequent messages will be encrypted. Both client and server send finished messages, encrypted with the session key to confirm the handshake process is complete. Data transmission. With the session key established, the client and server can now exchange data securely using symmetric encryption. SSL/TLS Passthrough. In this scenario, TCPWave Themis ADC can effectively distribute TCP connections across multiple backend servers, ensuring optimal resource utilization, high availability, and scalability for TCP-based applications. And it will not perform any SSL offloading function in this method. Here TCPWave ADC acts as a pass-through only. Client-initiated encrypted data is sent to the backend servers. SSL Passthrough Explanation. There are multiple steps in the SSL passthrough process. First, clients initiate secure requests, often over HTTPS, which uses SSL/TLS encryption for secure communication. These requests are typically directed to a web service. The encrypted requests from clients arrive at the TCPWave load balancer. Load balancer frontends. The TCPWave load balancer is equipped with specialized frontends configured to handle encrypted traffic, such as HTTPS on port 443. Traffic remains encrypted. Unlike SSL offloading, where the load balancer decrypts the traffic, in SSL Passthrough with TCPWave, the load balancer does not decrypt the HTTPS traffic. It ensures that the traffic remains encrypted as it forwards the requests. TCPWave Load Balancer routes traffic. The TCPWave load balancer intelligently routes the encrypted traffic to the appropriate back-end servers based on various load balancing algorithms. Back-end servers with SSL certificates. The back-end servers are equipped with SSL certificates necessary to decrypt incoming encrypted traffic. Servers decrypt and process requests. Upon receiving the encrypted requests, the back-end servers use their SSL certificates to decrypt the traffic. They then process the user requests as needed. Servers send encrypted responses. After processing the requests, the back-end servers generate responses and send them back to the users in an encrypted form. Load balancer forwards encrypted responses. The TCPWave load balancer forwards the encrypted responses back to the clients, ensuring that encryption is maintained throughout the entire communication cycle. Load balancing algorithms. Now, let's delve into the heart of TCPWave Themis ADC's intelligence. Its load balancing algorithms. These algorithms determine how client requests are distributed across available back-end servers, ensuring optimal performance and resource utilization. Round robin. A commonly employed load balancing algorithm systematically allocates requests across available servers, promoting an equitable distribution of the workload. Least connection. This algorithm directs requests to the server with the fewest active connections, ensuring fair and balanced load distribution. Static round robin. This algorithm assigns a fixed weight to each server, allowing for customized load distribution based on server capacity or performance. First. This algorithm assigns users to the first available server until that server reaches its maximum allowed connections. Once the limit is reached, the next available server is used to handle additional user connections. This process repeats as users connect, ensuring that servers are utilized in order, one at a time, based on their availability and connection limits. Source. This algorithm uses the source IP address of a user to determine which server they should connect to. It does this by converting the IP address into a unique number, hash, and dividing it by the total weight of all the servers that are currently running. This ensures that a particular user consistently connects to the same server as long as that server is operational. If the number of running servers changes, the hash result also changes, and users may be directed to a different server. This method is commonly employed in TCP mode, where it's not possible to insert cookies. Random. The random algorithm used by a load balancer distributes incoming requests evenly across available nodes by randomly selecting a node for each request, ensuring a balanced load without following any specific pattern. Additional features. TCPWave Themis ADC goes beyond basic load balancing, offering advanced features like health checks. Continuously monitor the health of back-end servers and automatically remove unhealthy ones from the pool. Session persistence. Maintain consistent client connections to the same server for improved user experience and application performance. Traffic shaping. Prioritize critical traffic and throttle less important requests to optimize resource utilization. Geolocation routing. Route clients to geographically optimal servers for faster response times and lower latency. TCPWave Themis ADC is a powerful and versatile application delivery solution that empowers businesses of all sizes to achieve unparalleled performance, scalability, and security. With its advanced technology, intelligent algorithms, and comprehensive features, TCPWave Themis ADC delivers a truly transformative application delivery experience. Visit our website today to learn more and experience the power of TCPWave Themis ADC.